Welcome back to our course on Python in data science. In this lecture we will discuss about Python variables and data types. Today we'll learn how to name variables in Python, different approaches, the rules and conventions for naming them, and some of the basic data types used in Python. We'll also cover how to identify the data type of an object, verify if an object is of a certain data type, and convert objects to a new data type. Additionally, we'll explore the difference between statically and dynamically typed programming languages, with Python being an example of a dynamically typed language. We will start with naming the variables. In any programming language, a naming of variables is an essential because variable names are created to provide information about their purpose. Choosing a meaningful variable name can make your code more readable, and easier for other developers to understand and maintain. Some of the best practices and guidelines for naming variables in Python are: keep variable names short but descriptive. Variable names should be concise but informative, clearly indicating their purpose. For example, instead of using a vague name like x, you could use count or total to provide more context. Second, avoid using variable names that clash with built-in functions. Python has many built-in functions, such as sum, print, and list. To avoid confusion, it's best to avoid using these names for your variables. For instance, instead of using sum as a variable name, you could use total or summation. Third, avoid using single-letter variable names. Single-letter variable names can be ambiguous and hard to understand. It's generally a good idea to avoid using one-letter variable names, except in specific cases like iterations, functions, and looping constructs. Fourth, use alphanumeric variable names. Variable names can contain a combination of letters and numbers. You can use both lowercase and uppercase letters in your variable names. For example, if you have a variable called age, you can write it entirely in lowercase or begin with an uppercase letter, such as age or age of employee. Fifth, add numbers to variable names. You can include numbers in your variable names, but the first character must always be a letter. For instance, age2 is acceptable, but toAge is not. Sixth, use underscores in variable names. The only special character allowed in variable names is the underscore. You can use an underscore to separate words in a variable name, such as employee_ID. However, it's best not to begin or end a variable name with an underscore, as this is not a common or accepted naming convention, even though it's allowed by the compiler. Common case types for naming variables are: camel case. In camel case, the first letter of each word is capitalized, except for the first word in lower camel case. For example, age of employee, lower camel case with first letter A in lower case. Camel case is commonly used in object-oriented programming and for function names. To follow the camel case naming convention in Python, you should adhere to the following guidelines. Begin with a lowercase letter for the first word. Capitalize the first letter of each subsequent word. Do not use spaces or special characters, except for the occasional underscore when necessary to separate numbers or special characters from the rest of the name. Be descriptive and concise with your names. Avoid using abbreviations or acronyms unless they are widely recognized. While camel case is not as commonly used as snake case in Python, it is still an acceptable naming convention in certain contexts. Some developers and organizations may prefer using camel case for specific purposes, such as naming private methods or variables that follow a specific pattern. However, it is essential to maintain consistency within a project and adhere to the naming conventions agreed upon by the team or specified in the project style guide. Second is snake case. In snake case, words are separated by an underscore, and the first letter of each word is in lowercase. For example, age_of_employee. Snake case is the preferred naming convention for variable names in Python. To follow the snake case naming convention in Python, you should adhere to the following guidelines. Use all lowercase letters. Separate words with a single underscore. Do not use spaces or special characters, except for the underscore. Be descriptive and concise with your names. Avoid using abbreviations or acronyms unless they are widely recognized. Using snake case consistently in your Python code can make it more readable and easier to understand for other developers. It is a widely accepted naming convention in the Python community and is recommended by the Python Style Guide, PEP 8. By following this convention, you can write cleaner and more maintainable code. 3. Pascal case. In Pascal case, the first letter of each word is capitalized, including the first word. For example, age of employee. Pascal case is typically used for class names in Python. To follow the Pascal case naming convention in Python, you should adhere to the following guidelines. Capitalize the first letter of each word, including the first word. Do not use spaces or special characters, except for the occasional underscore when necessary to separate numbers or special characters from the rest of the name. Be descriptive and concise with your names. Avoid using abbreviations or acronyms unless they are widely recognized. While Pascal case is primarily used for class names in Python, some libraries or frameworks may use it for function or method names as well. It is essential to maintain consistency within a project and adhere to the naming conventions agreed upon by the team or specified in the project style guide. By following these conventions, you can write cleaner and more maintainable code that is easier to read and understand for other developers. Now we will discuss about some commonly used data types in Python with examples. First one is Boolean data type. In Python, the Boolean data type represents a logical value, which can be either true or false. These Boolean values are often used in conditional statements, control flow, and logic operations. The statement is student equals true, assigns the value true to the variable. This means that the variable now holds the Boolean value true. Similarly, the statement is teacher equals false assigns the value false to the variable. Here's a more detailed explanation. The variable is student is created if it didn't exist before and assigned the Boolean value true. This variable could represent a condition or state, such as whether a person is a student or not. If we were to print the value of variable, it would output true. Next is teacher equals false. The variable is created if it didn't exist before, and assigned the Boolean value false. This variable could represent a different condition or state, such as whether a person is a teacher or not. If we were to print the value of variable, it would output false. Integer. In programming, an integer is a data type that represents whole numbers, both positive and negative, without any fractional or decimal part. The integer data type is typically used to store and perform operations on whole number values. In Python, the integer data type is represented by the letters int. When you assign a whole number value to a variable, Python automatically recognizes it as an integer data type. Let's break down the example. Student_count equals 50. In this line, we are creating a variable named student_count and assigning it the value 50. The value 50 is a whole number, so Python automatically treats it as an integer data type. After this assignment, the variable holds the integer value 50. Now, teacher_count equals 10. In this line, we are creating a variable named teacher_count and assigning it the value 10. Similar to the previous line, the value 10 is a whole number, so Python automatically treats it as an integer data type. After this assignment, the variable holds the integer value 10. Complex number. In mathematics, a complex number is a number that consists of a real part and an imaginary part. The imaginary part is denoted by the letter j or I. The general form of a complex number is a plus bj, where a is the real part and b is the imaginary part. In Python, the complex data type is used to represent complex numbers. It is represented by the keyword complex. Let's break down the example. Complex number equals 3 plus 4j. In this line, we are creating a variable and assigning it a complex number value 3 plus 4j. The part before the plus operator, 3, represents the real part of the complex number. The part after the plus operator, 4j, represents the imaginary part of the complex number. Here, 4 is the coefficient, and j represents the imaginary unit. So, 3 plus 4j is a complex number with a real part of 3 and an imaginary part of 4. Float. In programming, a float, short for floating point number, is a data type that represents real numbers with decimal points. Floating point numbers are used to represent fractional or non-integer values. In Python, the float data type is represented by the keyword float. When you assign a number with a decimal point to a variable, Python automatically recognizes it as a float data type. Let's break down the example. Student average score equals 85.5. In this line, we are creating the variable and assigning it the value 85.5. The value 85.5 contains a decimal point, so Python automatically treats it as a float data type. After this assignment, the variable holds the floating point value 85.5. Teacher average experience equals 12.5. In this line, we are creating a variable is assigned at the value 12.5. Similar to the previous line, the value 12.5 contains a decimal point, so Python automatically treats it as a float data type. After this assignment, the variable holds the floating point value 12.5. String. In programming, a string is a sequence of characters, such as letters, digits, symbols, or even spaces. Strings are used to represent and manipulate textual data. In Python, the string data type is represented by the letters str. Anything enclosed between single quotes, double quotes, or triple quotes, is treated as a string data type. Let's break down the example. Student name equals John Doe. In this line, we are creating a variable and assigning it the value John Doe. The value John Doe is enclosed within double quotes, so Python treats it as a string data type. After this assignment, the variable holds the string value John Doe. The teacher name equals Jane Doe. In this line, we are creating a variable assigning it the value Jane Doe. The value Jane Doe is enclosed within single quotes, which is also a valid way to represent a string in Python. After this assignment, the variable holds the string value Jane Doe. Statically versus dynamically typed languages. Before we proceed with data type operations, it's essential to understand the difference between statically and dynamically typed programming languages. A statically typed language is one where the type of the variable is known at compile time, and you must declare the data type of the variables up front. Examples of such programming languages are C, C++, and Java. On the other hand, a dynamically typed language is one where the data type need not be declared up front, and the type of the variable is known only at runtime. Whenever you declare a variable and assign a value to it, the moment you run that specific line, the data type of the variable is known. Examples of such languages are Python and PHP. Python, which we are using here, is a dynamically typed language. The next topic is identifying the data type of an object. In Python, the type function is a built-in function that returns the type of an object. The object can be a variable, a data structure, like a list or a dictionary, or any other object in Python. This function is particularly useful when you're working with variables and need to determine their data types. Let's break down with the example. With the variable student_name equals John Doe, we assigned the string John Doe to the variable. And with the variable student_age equals 22, we assigned the integer value 22 to the variable student_age. And lastly, with variable student_marks equals 85.5, we assigned the float value 85.5 to the variable student_marks. We passed the variable student_name as an argument to the type function. The type function returns the type of the object passed to it, which is class string in this case. The output class str indicates that the variable student_name is of the string data type. Type student_age. We passed the variable student_age as an argument to the type function. The type function returns the type of the object passed to it, which is class integer in this case. The output class int indicates that the variable student_age is of the integer data type. Type student_marks. We passed the variable student_marks as an argument to the type function. The type function returns the type of the object passed to it, which is class float in this case. The output class float indicates that the variable student_marks is of the float data type. The type function is particularly useful when you're working with dynamic data or when you need to perform different operations based on the data type of an object. By determining the data type, you can ensure that you're handling the data correctly and avoid potential errors or unexpected behavior. It's worth noting that the type function returns the actual data type of the object, not just the data type you might have expected. For example, if you perform an operation that results in a different data type, the type function will reflect the new data type. Verifying the data type of an object. In Python, you can use the is keyword to check if an object belongs to a specific data type. The is keyword is used for testing object identity, which means it checks if two objects are the same instance in memory. In the context of verifying data types, we use the is keyword in conjunction with the type function and the data type name. This expression type, object, is data_type returns a Boolean value, true or false, indicating whether the object is of the specified data type or not. Let's understand with an example. We first use the type function to get the data type of the student_name variable, which is class string. Then, we use the is keyword to check if the data type returned by type, student_name, is the same as the string class. Since student_name is a string, the expression type is str evaluates to true. Type student_age is integer. We use the type function to get the data type of the student_age variable, which is class integer. Then, we use the is keyword to check if the data type returned by type, student_age, is the same as the integer class. Since student_age is an integer, the expression type is int evaluates to true. Type student_marks is float. We use the type function to get the data type of the student_marks variable, which is class float. Then, we use the is keyword to check if the data type returned by type, student_marks, is the same as the float class. Since student_marks is a float, the expression type is float evaluates to true. As mentioned, the output of these expressions will always be a Boolean value, true or false, indicating whether the object is of the specified data type or not. Verifying the data type of an object is useful when you need to perform specific operations based on the data type or when you want to ensure that the data you're working with is of the expected type. This can help prevent errors and ensure the correct behavior of your code. Converting objects to new data types. Now, let's look at how to convert the data type of an object to another type in Python. To convert the data type of an object to another, you can use the desired data type as a function and provide the object as input. For example, if you want to convert the student_marks variable from float to integer, you can use the integer function. However, keep in mind that only certain types of conversions are accepted in Python. For example, you cannot convert a string data type to an integer or float data type if the string does not contain a valid numeric value. In the case of the student_marks variable, you can convert it to an integer data type using the int function, but the conversion will result in the loss of the decimal part of the number. If you want to store the converted value in a new variable, you can do so as follows: int student marks equals int student underscore marks. Now, if you check the data type of the int student marks variable, it will be of the integer data type. If you want to reflect the changes in the same variable, you can assign the converted value back to the original variable as follows: student marks equals int student marks. Now, if you check the data type of the student marks variable, it will be of the integer data type. In summary, in this course, we have learned some common naming conventions for variables in Python. We have also discussed some basic data type-related operations, such as identifying the data type of a variable, verifying if a variable is of a certain data type, and converting the data type of an existing variable to a new one. We have also explored the difference between statically and dynamically typed languages, with Python being an example of a dynamically typed language. Understanding these concepts is essential for writing clean and efficient Python code for data science projects. We hope you found this information helpful and enjoyable. If you did, please take a moment to like and subscribe to our channel. By subscribing, you'll stay updated on our latest content and ensure that you don't miss out on any future videos. Your support will help us continue creating high-quality content tailored to your learning needs. Thank you for your time, and we look forward to seeing you in our next video.